So an astronaut walking on Venus would first sink into the molten surface, be crushed by the atmosphere, and then burned alive by sulfuric acid rain.
Did you catch wind of Michio Kaku dropping some never-before-seen pictures of Venus that were once classified by the Soviet Union? Space enthusiasts, brace yourselves. These images are like nothing we've seen before, and word on the cosmic street is that they might spill some long-held secrets about Venus, our fiery neighbor. What could these old snapshots, snapped by Soviet cameras, reveal about this mysterious planet? Is it possible we're on the brink of reshaping our cosmic understanding? Join us on a journey through the cosmos with Michio Kaku as we dig into this celestial treasure trove, unveiling mysteries that have been tucked away among the stars for years. The cosmic race. Let's rewind to the Cold War era, the backdrop for what we now call the space race. As soon as World War II wrapped up, the United States and the Soviet Union locked horns in a competition that extended well into the 1980s. Beyond military and politics, this rivalry spilled over into the realms of technology and science, with space exploration becoming a major battleground. It was a time of monumental leaps in space tech, all fueled by the desire to outshine the other on the cosmic stage. The space race wasn't just about exploring the vastness of space, it was also a grand stage for showcasing technological prowess and national potential to the world. The Soviet Union, especially, was eager to flaunt its capabilities in this arena. A game-changing moment occurred in 1957 with the launch of Sputnik, the world's inaugural artificial satellite. This event was groundbreaking, marking the dawn of a new era in space exploration. As Sputnik circled the Earth, emitting its distinctive beeping, its impact was colossal. It signaled the beginning of a fresh race, not only toward the stars, but also for global prestige and acknowledgement. So, why all the buzz about Venus during this time? Well, Venus happens to be our closest planetary neighbor. It shares many similarities with Earth in terms of size and composition, earning it the moniker Earth's sister planet. Yet, like any siblings, there are notable differences, sparking curiosity about just how akin Venus truly is to Earth. Could it potentially serve as a second home for humanity among the stars? These questions piqued the curiosity of both scientists and the general public, driving the Soviet Union to seek answers. Thus began the era of the Venera missions. The Soviet Union embarked on a series of missions known as Venera, dedicated to unraveling the mysteries of Venus. These endeavors aimed to study the planet's atmosphere, surface, and overall environment. Michio Kaku's book highlights the significance of the images captured by the Soviet Union's Venera probes, which remain the only spacecraft to have returned images from the surface of another planet. It's worth noting that Venus attracted numerous missions during this period. However, exploring Venus is no walk in the park. The conditions there are incredibly harsh. We're talking about temperatures high enough to liquefy lead, clouds filled with sulfuric acid, and atmospheric pressure so crushing it could flatten a human. Nevertheless, the Soviets were undeterred. They were prepared to confront these daunting challenges. The inaugural mission in this ambitious endeavor was Venera 1, launched in 1961. Unfortunately, it didn't go as planned. Instead of reaching Venus, Venera 1 zoomed past it at a staggering distance of 62,000 miles. Rather than giving up, the Soviet Union displayed remarkable resilience. They swiftly regrouped and sent Venera 2 into orbit the following year. Despite their best efforts, Venera 2 met the same fate as its predecessor and failed to reach Venus. However, as the saying goes, the third time proved lucky. The Soviet Union remained hopeful and launched Venera 3 in 1965. This time, they hit the jackpot. Although Venera 3 didn't execute a graceful landing, it crash-landed to be precise, it still transmitted valuable data back to Earth for a brief period before succumbing to Venus's harsh environment. This event marked a pivotal moment in the Soviet Union's space exploration strategy, They realized that to gather significant data from Venus, their spacecraft needed substantial upgrades. Thus, they went back to the drawing board, enhancing the spacecraft's resilience and equipping them with state-of-the-art tools. Each spacecraft now featured a detachable pod called a descent module, loaded with an assortment of instruments including barometers, radar altimeters, gas analyzers, and thermometers. The goal was to maximize data collection during the short time the descent module could withstand Venus's surface conditions. Now, returning to the intriguing aspect of your inquiry, what did the Soviets unearth on Venus that remained concealed? To unravel this mystery, we may need to delve deeper into historical data, scrutinize records from subsequent Venera missions, and possibly review declassified documents from the Soviet space program. You see, the exploration didn't halt with Venera 3. The Soviet Union pressed on with the next mission, Venera 4, and it was a game changer. This spacecraft successfully touched down on Venus's surface. Yet, it wasn't just the landing itself that garnered attention. It was the groundbreaking discoveries it made once it reached its destination. Venera 4 made a groundbreaking revelation. Venus's atmosphere was densely packed with carbon dioxide. Now, you might be wondering why this finding is significant. Well, carbon dioxide acts as a greenhouse gas, trapping heat. With such a high concentration of carbon dioxide in its atmosphere, it's no wonder Venus boasts scorching surface temperatures, reaching up to a blistering 864 degrees Fahrenheit, hotter than even Mercury, the closest planet to the Sun. This discovery played a pivotal role in unraveling the climate and geology of Venus. Moreover, considering the parallels between Earth and Venus, it provided a glimpse into a potential future scenario for our own planet if greenhouse gas levels continue to rise. In many ways, Venus serves as a stark cautionary tale for Earth, illustrating the dire consequences of unchecked greenhouse gas emissions. But the revelations didn't end there. Alongside its carbon dioxide-rich atmosphere, Venera 4 also unveiled another striking fact. Venus lacks a global magnetic field. On Earth, our magnetic field serves as a protective shield, guarding us against harmful solar winds and radiation. Without it, life as we know it would be untenable. The absence of a similar magnetic field on Venus suggested that life, at least in the forms we're familiar with, might not thrive there. This discovery offered profound insights into the genesis and evolution of planetary magnetic fields, enriching our understanding of the habitability of other celestial bodies within our solar system and beyond. With each mission and every nugget of data collected, we edged closer to unraveling not just the mysteries of Venus, but also gaining deeper insights into our own planet and the vast universe beyond. These ventures to Venus transcended mere feats of engineering and space travel. They were odysseys of discovery, enriching our understanding of the cosmos. Venera 5 and 6. Regrettably, Venera 4's mission was prematurely terminated. After approximately 90 minutes of data collection, the harsh conditions prevailing on Venus took their toll, causing the probe to vanish into the planet's dense atmosphere, where extreme heat and pressure rendered it inoperative. However, those 90 minutes proved invaluable. The amassed data provided us with a unique glimpse into the enigmatic world of Venus. Following the promising success of Venera 4, 2 additional probes, Venera 5 and Venera 6, were dispatched toward Venus in 1969. These spacecraft were engineered to be more robust than their predecessor, armed with cutting-edge scientific instruments to gather even more precise atmospheric data. Venera 5 was launched on January 5, 1969, with a mission profile akin to Venera Thor, to descend into Venus's atmosphere and collect data during its plunge. As Venera 5 penetrated the Venusian atmosphere, it released a capsule containing a suite of scientific. For 53 minutes, while descending under its parachute, the probe transmitted valuable data back to Earth. It analyzed Venus's atmosphere's chemical composition, oxygen and hydrogen distribution, atmospheric density at various altitudes, as well as atmospheric lighting and temperature. Now, let's turn our attention to Venera 6. Launched just 5 days after Venera 5, on January 10, 1969, it too was equipped with instruments to study cosmic particle streams, analyze oxygen and hydrogen distribution, measure atmospheric pressure, assess chemical composition and density of the atmosphere, and record atmospheric temperature. Venera 6 commenced its descent into Venus's atmosphere on May 17, 1969, following Venera 5 by a day. Throughout its descent, Venera 6 beamed data back to Earth for 51 minutes. Despite its photometer malfunctioning, it managed to provide data on the Venusian atmosphere at 2 bars and 10 bars pressures. Both Venera 5 and Venera 6 were designed with smaller parachutes due to Venus's dense atmosphere, ensuring the capsules would reach their full crush depth before losing power. The findings from these missions corroborated Venera 4's discoveries, affirming Venus's high temperatures, pressures, and carbon dioxide-rich atmosphere. This reinforced the understanding that Venus was inhospitable for life as we know it. And then came Venera 7 and Venera 8, integral parts of the Venera probe series aimed at exploring Venus, which provided significant data to Earth. Back in August 1970, Venera 7 embarked on a groundbreaking mission. It became the first spacecraft to achieve a successful soft landing on another planet and transmit data back to Earth. Designed to withstand the harsh conditions of Venus, the probe was equipped with sensors to measure temperature, pressure, and atmospheric density, alongside an accelerometer and a radar altimeter. The journey to Venus spanned some time, with a few course corrections made during flight using the onboard engine. Upon reaching Venus in December of the same year, the spacecraft had to navigate entry into the Venusian atmosphere. The entry process was intricate. The lander remained attached to the bus during the initial stages of atmospheric entry to maintain its coolness for as long as possible. After detachment, the parachute deployed, albeit experiencing later issues, resulting in a quicker descent than planned. Consequently, the lander struck the surface at approximately 59 kilometers per hour. One might assume this to be a mission failure, but not quite. Despite appearing silent upon impact, the recording tapes continued rolling, revealing another 23 minutes of extremely faint signals weeks later. This confirmed Venera 7 had indeed landed on Venus, albeit bouncing onto its side and misaligning the antenna for proper signal transmission to Earth. During its brief stint on the surface, the probe managed to transmit data for about 20 minutes, recording a surface temperature of roughly 887 degrees Fahrenheit and estimating a pressure of about 1,300 psi. Now, shifting focus to Venera 8, launched in 1972. It pursued a similar mission with some notable distinctions. Like its predecessor, the probe aimed to study Venus's atmosphere and surface, but this time, the landing was considerably smoother. Venera 8 boasted an array of sensors, including those for temperature, pressure, and light, alongside an altimeter, gamma-ray spectrometer, gas analyzer, and radio transmitters. The journey to Venus lasted approximately 118 days, with a mid-course correction implemented en route. To enhance its survivability on the surface, the descent capsule was pre-chilled before atmospheric entry. Utilizing aero-braking techniques, the descent speed decreased from about 41,696 kilometers per hour to approximately 900 kilometers per hour, and the parachute deployment occurred at an altitude of 60 kilometers. During its descent, Venera 8 transmitted data, observing a decrease in illumination between 35 to 30 kilometers altitude and recording wind speeds below 10 kilometers per second. Ultimately, the lander touched down in what is now known as Vasilisa Reggio, bathed in sunlight and positioned roughly 500 kilometers from the morning terminator. Following landing, Venera 8 continued transmitting data for slightly over 50 minutes before succumbing to the harsh surface conditions. It corroborated the high surface temperature and pressure findings of Venera 7 and also gauged the light level, determining it suitable for surface photography akin to an overcast day on Earth with approximately 1 kilometer visibility. Furthermore, Venera 8's photometer measurements unveiled a significant revelation. The clouds on Venus terminate at a high altitude, leaving the atmosphere relatively clear down to the surface. Moreover, the onboard gamma-ray spectrometer analyzed the ratio of uranium, thorium, and potassium in the surface rock, indicating a similarity to alkali basalt. Both Venera 7 and Venera 8 marked significant milestones in our exploration of Venus. Despite encountering challenges, including Venera 7's less than optimal landing, the Soviets persevered. They meticulously analyzed setbacks, gleaned invaluable lessons, and applied those insights to refine their subsequent missions. Thanks to the data relayed by Venera 8, scientists grasped the staggering atmospheric pressure on Venus, a daunting 90 times that of Earth's at sea level. Despite this immense pressure, Venera 8's sensor persevered, offering valuable readings. Additionally, in a groundbreaking revelation, the probe captured ambient light levels on the Venusian surface, hinting at the feasibility of utilizing cameras for visual data collection from the planet's terrain. However, the Soviets' ambition extended beyond mere touchdown. They yearned for a first-hand glimpse of Venus's appearance, laying the groundwork for future endeavors. Enter Venera 9 to Venera 12, which heralded a new and thrilling phase. Armed with cameras, these probes embarked on visually documenting the planet, unveiling humanity's inaugural views of Venus's intriguing, rugged topography. Though the initial images lacked perfection, they unveiled a vista of harsh, unwelcoming landscapes marked by impact craters, jagged cliffs, and expansive plains submerged in ancient lava flows. Then, in 1981, Venera 13 and 14 followed suit, each boasting enhanced capabilities. These later probes featured landers equipped with cutting-edge acoustic instruments capable of measuring surface wind's velocity on Venus. Yet, the true game changers emerged with Venera 15 and 16. Ditching the landers, these spacecraft instead sported robust radar-based imaging devices, enabling comprehensive mapping of Venus's surface from eccentric orbits. They delivered images with a resolution of approximately 1 mile per pixel, furnishing scientists with intricate snapshots of Venus's terrain and uncovering the planet's true surface characteristics. Each successive mission unfolded like a new chapter in a book, offering fresh and tantalizing insights into Venus. Naturally, not every mission unfolded flawlessly. Many of the onboard cameras succumbed to the harsh conditions, but a resilient few persevered, capturing and relaying the first-ever photographs from the surface of our solar system's second planet. Throughout their comprehensive exploration, the Venera probes encountered no traces of life on Venus. The barren world revealed no oceans, lakes, or even a solitary droplet of water. However, the probe's investigations yielded invaluable revelations about the extreme environments of alien planets, expanding our comprehension of the diversity among celestial bodies. While the absence of life might initially seem disheartening, the probes unearthed a plethora of captivating discoveries. Notably, Venera 13 achieved a historic milestone by recording the eerie sounds of Venus's winds, marking the inaugural occasion of capturing sound on a planet beyond our own. This moment stands as a poignant highlight in our odyssey of space exploration. Despite the myriad challenges and setbacks, the Venera probe's legacy endures, serving as a perpetual wellspring of inspiration for further ventures aimed at unraveling the mysteries of our cosmic neighbors. However, Venera 13's significance transcended capturing alien winds. Its endurance surpassed expectations, operating for an impressive 27 minutes on Venus's unforgiving surface, despite being initially designed for just 45 minutes. Throughout this prolonged operational phase, it succeeded in capturing and transmitting breathtaking color images of the planet, revealing a stark and barren landscape unlike any we had previously encountered. Yet, the revelations didn't cease there. Venus's soil asterisk asterisk. Venera 13 also delved into the Venusian soil, known as regolith, and conducted an analysis of a sample. This marked humanity's inaugural examination of another planet's soil composition. Through this venture, we uncovered the presence of elements such as titanium and iron on Venus. It's truly remarkable that we could glean such profound insights about a planet situated over 100 million kilometers away from us, particularly considering this transpired in the 1980s. However, as our understanding of Venus deepened, it became increasingly evident that it is highly improbable to sustain life as we know it. Venus's atmosphere is nearly 100 times denser than Earth's, and its surface is subjected to scorching temperatures. Far from resembling a serene tropical haven, Venus paints a formidable picture with its retrograde rotation and its absence of oceans or bodies of water akin to those found on our blue planet. Despite these formidable conditions, our exploration of Venus is far from complete. Russia's space agency, Roscosmos, is currently developing a new mission to Venus dubbed Venera D, scheduled for launch in 2029. This ambitious endeavour will feature both an orbiter and a lander, serving as a blueprint for future missions to Venus. You might be pondering why, given our comprehension of Venus's inhospitable conditions and its apparent incapacity to sustain life, we're contemplating further explorations. The answer is captivating. It appears that not all discoveries about Venus from the initial missions were fully disclosed. There's more to unveil about this fiery planet, and this enigma ignites the quest for further exploration. Phosphine. In the early autumn of 2020, a startling revelation emerged from scientists at the Massachusetts Institute of Technology. They had identified the presence of phosphine gas in the atmosphere of Venus. Why is this noteworthy? Well, phosphine gas could potentially serve as an indicator of life. Adding another layer of intrigue, there might be additional evidence bolstering this assertion lurking within the data archives of a NASA mission conducted over 40 years ago. The mission in question was the Pioneer Venus multiprobe mission, conducted in December 1978. This mission deployed 4 probes into the Venusian atmosphere, one of which was larger than the others and outfitted with an advanced instrument known as the Large Probe Neutral Mass Spectrometer, or LNMS for brevity. The primary function of the LNMS was to identify atmospheric molecules by measuring their speed upon collision with a detector. While the device was primarily tasked with detecting known molecules such as carbon dioxide, sulfur dioxide, and argon already identified in Venus's atmosphere, the sensitivity of the LNMS might extend beyond these compounds. It could potentially detect other molecules, including phosphine. This adds another layer of fascination to the ongoing exploration of Venus and its potential mysteries. Mogul proposes an intriguing theory. He suggests that scientists involved in the original mission may have overlooked the detection of phosphine while primarily focused on other aspects, analyzing the general characteristics of Venus's atmosphere with an emphasis on more well-known elements. Another theory he posits is even more mysterious: the possibility that information about phosphine was intentionally kept concealed. This secrecy could have been a strategic maneuver to gain an edge over other nations, particularly the US, as the predominant focus was on Mars and other celestial bodies. While global attention was diverted elsewhere in the solar system, the team could have been uncovering deeper insights from the wealth of data gathered from Venus. However, the actual situation isn't as clear-cut as it may appear. There's a crucial detail that might hold more significance than initially presumed. If Mogul's interpretation of the Pioneer mission data proves accurate, it could swiftly corroborate the recent phosphine detection by the MIT team. Yet, not all members of the scientific community are convinced that the LNMS possessed the sensitivity to detect phosphine. Mikhail Zolotov, a planetary scientist from Arizona State University, offers an alternative perspective. He suggests that what the LNMS may have identified is not phosphine itself, but rather a mixture of gases abundant in phosphorus and hydrogen sulfide. If indeed phosphine was detected by the LNMs, it could imply a much greater prevalence of the gas than what the MIT team uncovered. This disparity has sparked debate within the scientific community. Regrettably, the opportunity to verify and cross-check these theories is currently unavailable. The data from the Pioneer Venus multi-probe mission is securely archived on microfilm at NASA's Goddard Space Flight Center. The archive is currently restricted, meaning that access to the potentially enlightening information it contains is limited. Dr. David Williams, acting head of the NASA Space Science Data Coordinated Archive, indicates efforts are underway to obtain permission to digitize the microfilm. This initiative would enable comprehensive examination of the data without the need to handle the original physical records. In summary. The discovery of phosphine has ignited significant enthusiasm within the scientific community. Phosphine, being a gas potentially generated by living organisms, naturally sparks the tantalizing prospect of life existing on Venus. However, it's imperative to exercise caution. This remarkable revelation doesn't yet constitute conclusive evidence of extraterrestrial life on Venus. To confidently confirm the presence of phosphine, further data collection is necessary. This could involve deploying atmospheric probes capable of directly detecting the gas or meticulously scrutinizing archived data from previous Venus missions. Systematically gathering and analyzing additional data will empower scientists to confirm the presence of phosphine and make a more informed assessment regarding its origin, whether biological or non-biological. Validating these findings is paramount. The notion of life on another planet represents a groundbreaking discovery that could fundamentally alter our understanding of the universe and our place within it. However, in the pursuit of such profound revelations, ensuring the accuracy and reliability of the data is equally crucial before any definitive conclusions are drawn. Consequently, scientists will persist in their exploration of Venus, striving to validate the presence of phosphine and uncover other potential indicators of life. Should they succeed, it could herald a paradigm shift in space exploration, refocusing attention on Venus and the possibility of a planet resembling a second Earth. Such a discovery has the potential to reshape our perception of the cosmos and redefine our approach to the search for life beyond our home planet. What are your thoughts on this? Do you envision Venus becoming habitable for humans one day? Or do you foresee Earth resembling Venus in the decades to come? Share your insights in the comments. Stay tuned for more thought-provoking content.